What came before the Big Bang? Exploring the mysteries beyond time and space. In the realm of science and cosmic mysteries, few questions stir the imagination like the one asking what existed before the Big Bang. This profound mystery has captivated thinkers and scientists for generations, not just because it probes the boundaries of our knowledge, but because it dares to question the very framework of existence itself. Picture standing on the precipice of all creation, peering into an immense unknown, pondering what might have preceded the birth of our universe. The Big Bang is commonly recognized as the starting point of time, space, and all known matter. But was there truly nothing before that moment? Or was there a silent, invisible state that set the stage for cosmic creation? The idea that something, or even everything, might have existed before the Big Bang challenges the limits of human comprehension. Physicist Brian Cox, known for exploring the wonders of the cosmos, suggests that we may need to rethink the entire concept of reality itself. Let's journey into theories, scientific models, and mind-stretching possibilities that attempt to answer what came before the beginning. We'll examine ideas ranging from rapid cosmic inflation and quantum fluctuations to the multiverse and the nature of nothingness. The answers might shake your view of the universe or open entirely new perspectives on our place within it. The Big Bang. What do we actually know? To understand what might have existed before the Big Bang, we must first clarify what the Big Bang really was. In scientific terms, it refers to the moment when the universe became incredibly dense and hot, then began expanding rapidly. From that singular event emerged all matter, energy, and the physical forces we observe today. Evidence of this explosive beginning is visible in every direction. Galaxies racing away from each other across the fabric of space. But why did this occur? And could something have come before? The inflating universe and the pre-bang vacuum, the theory of cosmic inflation, proposes that before the Big Bang, the universe was in a cold, empty-like state, not truly void, but a vast vacuum infused with hidden energy. This energy caused space itself to expand faster than the speed of light in an instant, a process known as inflation. As this expansion slowed, the energy transformed into particles, radiation, and the forces we now associate with the Big Bang. Crucially, this theory suggests that our universe is just one bubble in a greater cosmic foam, a multiverse of countless other universes, each formed from its own Big Bang. In this inflationary multiverse, space stretches infinitely, constantly spawning new universes. This concept, while awe-inspiring, raises profound questions. Could there be no ultimate beginning or end? Could our universe be just one flicker in a boundless cosmic tapestry? Is nothing really nothing? Even when stripped of all matter and energy, space is never truly empty. Quantum field theory tells us that what we perceive as nothing is actually teeming with invisible fields and fluctuations. Even in a vacuum, virtual particles briefly emerge and vanish, leaving behind a ghostly trace of their existence. This means that absolute emptiness, a total void, is likely impossible. Space itself carries structure, constants, and energy that prevent it from being truly nothing. At its quietest, the universe still vibrates with quantum motion, like a whisper in the dark. This redefines our understanding of the void. Could such restless emptiness be the source of everything? The puzzle of dark energy. Today, dark energy is known as the mysterious force accelerating the universe's expansion. But could this energy have existed before the Big Bang? Some scientists suggest that a more potent form of dark energy may have driven the inflationary phase, setting the stage for the universe we inhabit. If dark energy is indeed a remnant from a pre-bang reality, it may be the key to understanding what gave rise to our cosmos, and perhaps even countless others. This leads us to ask, is dark energy the architect of reality itself? The timeless universe. cycles. Without beginning, an alternative theory, known as cyclic cosmology, envisions the universe as a phoenix, constantly expanding, collapsing, and rebirthing in an eternal cycle. In this model, the Big Bang wasn't the beginning, but merely a transition point from one cosmic phase to the next. Each cosmic cycle could stretch and contract the universe, resetting reality over and over again, leaving no final origin, only transformation. A universe without before or after. Perhaps the most radical idea is that the concept of before the Big Bang doesn't even make sense. Time, as we know it, began with the Big Bang. In a multiverse or inflationary model, new universes could form endlessly without a singular beginning. If the cosmos is timeless, then asking what came before may be like asking what's north of the North Pole. Conclusion. The mysteries of what preceded the Big Bang push science, philosophy, and imagination to their limits. From quantum fields to multiverses, dark energy to cyclic time, every theory opens more questions than it answers. And yet, in exploring these ideas, we come closer to understanding not just where we came from, but what it means to exist at all. What came before the Big Bang? Exploring the edge of time and existence. The concept of cyclic cosmology challenges our traditional understanding of time by proposing that time may not be linear, but instead cyclical. If this theory holds true, it suggests that the universe has no true beginning or end. Rather, what existed before the Big Bang could have been a previous incarnation of the cosmos, one that collapsed and then gave rise to our current universe. For scientists, this idea offers a profound perspective. Perhaps the universe has always existed in one form or another, transcending conventional notions of time and origin. Among the most fascinating clues to what may have preceded the Big Bang are primordial gravitational waves. These ripples in space-time, caused by massive cosmic events, could hold traces of the universe's earliest history. If ever detected, these early-stage waves might provide insight into a pre-Big Bang state, acting as echoes or fingerprints of a prior cosmos. Discovering such waves would be a groundbreaking moment in cosmology, potentially reshaping our understanding of how the universe began. Quantum gravity adds another intriguing dimension to the puzzle. This emerging field aims to unify quantum mechanics with general relativity and offers the possibility of a deeper understanding of reality. In this framework, space and time are not smooth and continuous, but are composed of discrete, granular structures at the Planck scale. According to this theory, what we perceive as the continuous flow of space and time may have emerged from fluctuating quantum fields. The state before the Big Bang, then, might not have included time or space as we know them, but instead existed in a radically different quantum form. An alternate theory is the string landscape hypothesis, born from string theory. In this view, our universe is just one of countless others in a vast multiverse, each shaped by different physical laws and constants. Each universe could have emerged from its own Big Bang-like event, creating a seemingly infinite tapestry of realities. The notion that our universe is only one piece of a larger cosmic puzzle opens up the possibility that what came before the Big Bang was simply another universe, operating under entirely different conditions. Another bold hypothesis suggests that our universe might have originated from the singularity of a black hole in another universe. According to general relativity, the center of a black hole is a region where the fabric of space and time becomes infinitely curved, and the known laws of physics cease to apply. In this model, the Big Bang represents not a beginning from nothing, but a transition, a black hole from one universe birthing another. This idea implies that black holes could be cosmic seeds of new universes. Such theories force us to question the nature of time itself. Some physicists propose that time may have emerged with the Big Bang, meaning there was no before in any meaningful sense. If past, present, and future are all constructs that arose with our universe, then asking what existed before the Big Bang could be a fundamentally flawed question. Returning to cyclic models, they suggest the universe undergoes endless cycles of expansion and contraction. Each Big Bang may follow a Big Crunch, with the universe rebirthing itself repeatedly. These cycles might differ in form, evolving uniquely each time, but without a true beginning or final end. In this view, time may loop infinitely, and the universe is eternally renewing itself. Another avenue of exploration is the idea of a primordial soup, a dense, high-energy mixture of elementary particles that existed before stars and galaxies. Composed of quarks, leptons, bosons, and other particles, this early state may have set the stage for all cosmic structure. In some versions of this theory, the soup existed within a quantum foam, a realm where particles blinked in and out of existence due to quantum fluctuations. Studying this phase could reveal the processes that led to the emergence of the universe as we know it. Ultimately, the question of what came before the Big Bang remains one of the deepest mysteries in science. As our grasp of quantum physics, cosmology, and fundamental laws evolves, new and often paradoxical ideas will continue to arise. Even if we never fully comprehend what preceded the Big Bang, the pursuit of this knowledge pushes the boundaries of human curiosity, compelling us to venture deeper into the unknown realms of time, space, and existence itself.